Alright, yeah, happy Tuesday. So a couple fun things then. The ECE, PhD, dissertation, defense, if you're interested. See what's all involved there. IoT something, warehouse battery monitoring system through time serial forecasting. Sure, sounds fun. But then the other one is another assistant professor research talk, and there is food. So always a good draw. That's the 8th, 2 to 3. Sample efficient decision making models using human in the loop. So this would actually be pretty interesting for folks in data science as we look at how you do sample efficient things. Because when we get billions of points of data, we can't always crunch all billion of them. So we have to sample somehow. So managing how you're doing those sampling is really interesting here. So that should be a fun talk. And then cyber physical security of critical infrastructure, maybe not quite as interesting for us, but still cool stuff. Because all the great stuff in the world, and if you don't have good physical security, it goes out the door. So just a little bit unfortunate. All right, so let's go take a look. So we've got the sample midterm to go over today and talk about the midterm format, make sure you feel comfortable with it. Again, it's not meant to be obnoxious, it's not meant to be a huge high stakes test, high pressure. I hate that sort of stuff, and no one will ever ask you to do stuff from memory because it's stupid. They're going to pay you a lot of money to do it well, and to do it well, you're going to go use resources. So I would like to sort of model after that. So you get a free point just for acknowledging the academic integrity policy, that you won't cheat. Someone did a study on this, which was super interesting because the humans are just weird creatures, and they actually tested if you ask at the end of an exam, say, okay, I agree that I didn't cheat, or I certify I've done all my own work here, versus the beginning of an exam. More people actually cheated and said they didn't if you ask at the end of the exam versus asking them at the beginning of the exam, because it puts it in their head, okay, I've agreed not to cheat, I won't cheat because I said so during the exam, versus, oh, I might have already cheated, and I get to the end and it says I didn't cheat, well, I'm just going to lie now. Because our natural instinct is to protect ourselves. So we're like, oh no, of course I didn't cheat, I'm just going to say I didn't. So super weird, but first question, 1 free point. And then a bunch of quiz-style questions, literally from the quiz banks, the question banks from the quizzes. So should be free points for you, right? That's the goal. These are not meant to be hard. I'm just pulling out of the quiz bank questions that we've done for the chapter quizzes. I think I still owe you one on trees, but I'm not going to post it yet because I don't want it to be part of the midterm. So when I pull the midterm question bank, it'll just be on the quizzes we've done so far, just the first couple chapters there.
So are we going over all the questions?
I can if you want. I think I've just copy-pasted the same quiz questions from last time. I don't think I edited them very much. So the answers should be the same that they got corrected for you already. If you want to talk about any of the quiz ones, we can. I was going to go over the long answer ones. Those are the ones slightly more interesting. Yeah, so 15 total questions there. So 15 points out of 30 are quiz-style questions with 1 free point for acknowledging the academic integrity policy. And then 3 long answer style coding questions, but meant to be short. So my goal is that you could get these done in about 20 minutes or so, because they will take me 5 or less. So, triple that and add a little bit, and it's just an estimate. I hope it's close. But we've got some time. It's not a lot of pressure on this. So given the following in UML, write the class. So sort of UML-y looking, right? It looked a little better in my format. It didn't print out well here, but so our class diagrams. So I have the name of the class, the list of attributes, and the list of functions with all their types. Unified modeling language. We talked about class diagrams way back, I think at the start of this semester when we did our first project with them. The name of the class is pizza. It has an attribute for diameter in centimeters, which is we expect to be an integer. We have a toppings list, we expect to be a list. We have a base cost, which we expect to be a floating point value. A cost in cents per centimeter as a float, right? Again, labeling our units is always handy. And then base diameter in centimeters as an int. And then we'll have methods or functions for add topping that accepts a string and adds it to the toppings list. A method for get total cost, which returns, I don't know what happened here, times typo, base price plus the cost per centimeter times the number of centimeters over the base diameter. So it is the base diameter price is, hey, you get a 12-inch pizza. If you get a large, which is a 16-inch pizza, you're going to pay 6 centimeters, right? The difference times your cost per centimeter average here, number here. Just some sort of it will increase as you get a bigger pizza, essentially. We don't often order pizzas in centimeters, but it'd be nice if we could, right? And by the way, this is fun because this grows linearly versus growing the diameter of a pizza grows exponentially, right? Because your area gets bigger. Yay math. And then a method for set diameter in centimeters raises a value error if the value isn't greater than 0, so you can't give it a bad diameter, these sorts of things. So a quick little class. Not too much here. We'll go do this one in a minute. That was an example. So it'll be build a class. And it, has a little bit of error checking here with the value error. It's something pretty short and sweet for this one. All right. Another question then will be on something to do with 2D lists. Sort of nonsense things here. Generally, chatbots are bad at these sort of mathy problems. It's sort of the goal here. The idea is not you just copy paste into chatbot and give me an answer. Right? That's not English paper rules. You can't just give me an entire answer you found online. You can use it to help with pieces. Like, hey, how do I find out what a prime number is? Perfectly fair. That's a piece of the solution. That's not the entire solution, right? So we're going to return the sum of values in white squares minus the sum of prime values in black squares. Ignore the non-prime values. Or sorry, the sum of prime values in white squares minus the sum of prime values in black squares.
I didn't get it, I'm sorry. I didn't get it.
So if we imagine a checkers board or a chessboard, right? Every other square is white or black. So I'm going to have a 2D list, an 8x8 list. Right? One of those is white, and every other is black. So I don't know, whichever corner you want to count as the white square or the black square starting, fine. Every other one alternates. If the number in that spot is prime, we're going to add it. If it's on a black square, we're going to subtract it.
Only with prime.
Only prime numbers. So we have to go through every value, see if it's on a white square or black square, and then see if it's prime, and if it's on a white square, add it. If it's on a black square, subtract it.
Okay.
Yep, just some loop within a loop. Yep, it's not too bad. So 2D list question, classes question with value errors like error checking, error handling, exceptions, and then the last question will be on iterative and recursive functions. So this one is you write a iterative and a recursive function, so you have to do it both ways, that calculate the standard deviation given a list of numbers. And we're going to assume it's the population standard deviation. I think we did this in one of our first labs, right? We did the standard deviation calculation. Sounds familiar. I think we did it. It was a while ago. This stupid number keeps calling me, and no one I hate spam calls. All right, so we'll work through those ones. So recursive and iterative. So we're going to do both, right? It's just a loop, essentially, for some of these easy ones. I'm not going to give you one of the hard recursion ones. We don't need to do any backtracking. It's just using recursion as a loop, essentially, and then writing it iteratively. So one question on that for 5 points, one question on 2D lists for 5 points, and one question on classes for 5 points. So that makes up 30 points for the exam, right? And which makes up 15% of your overall score, if I remember right from the syllabus. Let me double check that. So I do need to make this timed though. So once you hit start on it, you'll have, I'll set it to like an hour and a half to click submit in Canvas. So unlike the chapter quizzes that you had all week on, just pick what time you want to spend 90 minutes on this and hit start. Right? Just that kind of levels the playing field for people who don't have a lot going on during these next 5 days versus people who do during the next 5 days. So anytime before 3:12 when class starts, you can take it. You got 90 minutes. That's the plan for that one. So whatever time you like to take exams, go for it. If something happens mid-exam, you lose internet access, Canvas screws up, just text me, call me. I just need a record that you had an issue rather than 2 days later, you call and tell me you had an issue with the exam 2 days ago. People do that to me sometimes. I'm like, I don't know. But usually it goes fine. Canvas is pretty good. We rarely have issues with it, so I'm not expecting any big issues there. All right, so let me fire up PyCharm and we can go through some of those example questions. Yeah, you should be able to see all your quizzes, right? I think I made it so you can go back and see your questions and answers in the quizzes. If you can't, let me know, but they should be open to you.
Yeah, no, it's already open here.
Okay.
You want to see if I have access to quiz then?
Yeah, just can you see your questions and answers? Or see at least your questions and if you get the points?
Quiz.
On any of the quizzes that are out there. Yeah.
Oh, okay.
They all should be open.
Yeah, they're okay. Like the previous quiz would take, right?
Yeah, so can you click on it and see all the questions still?
Yeah.
Yeah, okay, cool. So there's a setting that like hides that. Just, I don't know, some of the default settings are super weird, but that's fine.
But is the midterm going to be similar to that one?
So I'm going to use the question banks from the quizzes. They'll be the quiz questions.
Oh, okay.
Yep. I call them quiz style questions, but I'm too lazy to rewrite them, and it's a quiz. Like, it's fine.
So the midterm is going to be based on the quiz.
Half the 15 questions from the quizzes, or 14 really, like the academic integrity policy, and then 14 quiz questions, both from the quiz banks, and then the 3 long answer questions. That's it for the 30 points. All right, and we'll do this midterm review project here. I'll post this in the GitHub. All right. Why would it start like halfway open? Oh, I guess because that's the length of this path. It's not useful. All right. So we're going to do our class for pizza. Right? So we're going to define our init method. Now, it doesn't specify, do we need to have things passed in init versus have set methods? It's totally up to you. If you want to write set methods, set functions, go for it. If you want to just take them in the init method, the constructor, go for it. The only one you have to have is the diameter in centimeters.
So in the question, they're just asking for like making the class pizza and
Yep.
then putting in the stuff that's mentioned.
Yeah, so these are the attributes here, and then these are the functions.
Yeah.
Yep. So I like putting values in the init method and then not having set methods for them. I don't think set toppings really makes sense because we haven't add toppings. I wouldn't mark you down if you had a set toppings, but it doesn't really make sense based on how this is worded. Again, there's a lot of this like the interpretation piece. Yeah.
When you say base cost float, is there a way for us to specify that it is a float?
You can in Python 3. Yeah. Remember we can give the type hints with the colons in Python 3. It's some people, it's getting more common in older Python code and not in Python 2 at all. So most people who have been with Python for a while don't do any of this, but it's useful sometimes to suggest it as a float. It doesn't super matter because Python will take an int or a float, but just so that we know we should be expecting a number with some decimal places.
Can you please show that?
Yeah, yeah. So we've got our pizza for init, so we'll have self dot, what do we have here? Diameter in centimeters. Diameter in centimeters, meters. So let's take that as an argument. So we say diameter in centimeters as an int, right? I think I said that as an int, right? Because you probably don't have half a centimeter. You could, I guess, but sure, right? Will be my diameter in centimeters. So we're saying, hey, you should give me an int when you call this init method. So later when you go make a pizza, right, if that's our only one here, you'd say, hey, you know, Eric's pizza equals a pizza, and then it shows me, hey, this should be an integer value here. So you get that information in this little pop-up, this IntelliSense here. So it's useful for people, so I don't have to go figure out what value it should be or what type it's expecting. So it's useful information, but it's optional stuff. You know, I still can give it 10. It's going to warn me and say, hey, it expected type int, it got a string. It'll still run because Python's cool like that. But it's going to warn you, hey, if it expects an int, you probably did a bad thing here, right? That's all this is. Yep.
Thank you.
So we got the diameter in centimeters. We had the, I can close those other ones, sorry. Make that easier. Now, I don't think we need to set toppings because we probably just use this add toppings method, right? I don't think I need to take a list of toppings. Probably I want to take the base cost, probably take the cost in centimeters, and then the base diameter in centimeters. Right? Those ones I think make sense for me to take. And again, that's all, as long as it works, great. As long as you can set those values somehow, I'm cool with it. So either in the init in your constructor or with a set function.
So are we supposed to come up with these values?
But you don't actually have to make any pizzas. We're just writing the class. So like that first project, you just have to make the class. You don't have to do anything with it.
Oh, okay.
So someone else will make the pizzas, right? Or set up the pizza ordering system or whatever nonsense we want to have, right? We're just doing, here's the class for it.
We don't need to actually have numbers for those, right?
Yeah, we don't need any numbers. So base cost is like what was that, a float, I think, right? Base cost, yeah, it's a float. So we'll say self.base cost, base cost. And again, if these are private, right, I probably want to add in these underscores. That's more proper here. I don't care if you do that or not, right? It's good practice to have these things be indicated as private, but you did it once for me. I'm not going to make you do it every single time because I know you know how. That's all. And then we'll have, what's our next one here? cost in cents per centimeter. All right, it's a little long to type out here. I feel a little bad, but that's okay. So if it's in cents, that's probably an integer, right? You're not charging half a penny for that one. So self dot cost in cents per centimeter, and then the base diameter in centimeters. And again, that's probably an integer value. It doesn't like all my spaces here. I hate that. I like spaces in things. All right. Getting rid of the yellow lines makes me happy. Base diameter. The line's too long. Yeah, thank you. Thank you for warning me. Let's see. Can I cut that down one maybe? All right. And then I need my self.toppings is a list. Then I can start adding toppings here. So I think I've got all my attributes that I need here.
So when it's a list like that, we don't need to mention it in the brackets at the start?
No, because we're going to add, so the way we interact with toppings is the add toppings function. Right, so if you want to add toppings, you have to go call this function here to give me something. I don't have a way to remove a topping, so once you add anchovies, you're stuck with anchovies. You don't get to change your mind anymore. Sorry for you. That's okay. Right? We could add that if we wanted to at some point, but for this purpose here, it's not very useful here. Right. So then we'll have, add toppings. That takes a topping. And we're going to take our self.toppings, and we're going to append the topping. Right. You tell me what topping, I'll go add it to my list here. Right. Then our get total cost returns the base price plus the cost in cents per centimeter times the number of centimeters over the base diameter. Okay, so get total cost. Get total cost. Don't need any arguments here. So we're going to return my, now this might be better as 2 lines. You could do one of these silly little ternary expressions if you want, but our base cost, right, so our total cost will equal the base cost to start. And then if my self dot diameter in centimeters is greater than the self dot base diameter in centimeters.
Do we need to do that?
So we're going to see if you ordered larger than the base size. So we're going to say base pizzas are 12 centimeters or 20 centimeters, I forget, whatever it works out to be. Right? 20 centimeters is our normal size pizza. If you wanted the 24 centimeter pizza, now you have to pay for those 4 extra centimeters. Right? So this is our way to charge more for a large, charge more for extra large, those sorts of things.
But we need to check it out.
Yeah, so because you only are going to add it if you've ordered larger than the base size. So the base size is, here's the small, this is the regular cost. That's your base cost. If you got bigger than a small, now we're going to start charging you per centimeter.
Okay.
I'll take my total cost plus the self dot diameter in centimeters minus the self dot base diameter times, and make sure we do some order of operations here. This is the silly little gotcha here, but trips people up all the time, right? Self dot cost in cents per centimeter. I need my backslash. There we go.
So why are we taking away the diameter minus the base diameter?
So like if you want a 24 centimeter pizza, you only have to pay for the 4 extra centimeters because the base diameter is 20.
So we have to assign that the base one is 20?
Well, whatever value I give you. So what, my small pizza will be a 16 centimeter pizza. The Domino small pizza might be a 20 centimeter base pizza. I don't know. Jets is a different size. Whatever it happens to be, right? So whatever base is, that's our base. That's the base cost. So you're paying a fixed amount per centimeter more as you get larger pizzas. Sort of the idea here.
What is it? Can you please go back to that? Yeah. What is the difference between base cost, cost in cents, and base diameter?
So base cost will give you the base diameter in centimeters size pizza. So a 20 centimeter pizza is my small pizza. The base cost is $10. So if you just order a 20 centimeter pizza, it will cost $10.
Okay.
If you order a larger than 20 centimeter pizza, now I'm taking $10 plus the cost per cents per centimeter more than 20. Or whatever that value happened to be, right? Because these are all variable. Maybe I make those like personal 12 centimeter pizzas or something, right? Those really, really tiny ones you can microwave. Sure.
Oh, okay, perfect.
Yep. So only if this happens do I add to the total cost. And then I'm done, I return total cost. If you didn't order larger than the base diameter, I don't charge you more. Maybe you only wanted a 5 centimeter pizza because you're on a diet. I'm still charging you for the 20 centimeter pizza because that's my base cost, right? We build in base costs and things like that for labor and all these other things, but that sort of idea. So here's get total cost, right? And then a set diameter in centimeters, we need to raise the value error. So if we're going to do that, we probably should be doing it up here as well, right? I can't just take a value. I should be checking to make sure that value is valid here. So we'll define a set base or diameter meter in centimeters. Given a diameter in centimeters, copy paste that one here. And I can check, hey, if the diameter in centimeters is less than 0, raise a value error. Otherwise, self.diameter in centimeters is equal to the diameter in centimeters. And then I can use this function here, right, to not have to have the same code twice and feel bad about myself.
Yeah, can't you just define that, like to raise the error in the init function?
We could, but then I'd have to have it twice. I don't like having it twice. So it's technically bad form to set self values not in the init, but because init calls it, I don't care. It's fine.
So why did you change that at the top, like from what it was?
Because I wanted to make sure that when you called the init method, if you gave it a -5, I also raised the value error.
Yeah.
And I didn't want to have to type the same code twice. I could. It would work. But this way, I'm also checking for valid diameters when I init, and if you go and change it later.
So you put like the name of the function.
Yeah, I just call the function right in the init method. Yep. Cool, and that's pizza. I guess, so that's greater than 0, so maybe I should say greater than or equal to 0. 0 is not valid either. You can't have a 0 centimeter pizza. I mean, I'll charge you $10 and give you nothing, I guess, but it's one of those silly things. So, yeah, because who knows what values people are going to give me. So, that sort of thing. So this is sort of the idea. So here's the name of the class. Here's a list of attributes. Here's some functions you got to write for it. One of them will have a value error checking, make sure this is a valid value within range or something. That sort of thing. That make sense? All right, cool. So there's pizza. The next one then was sum of white primes minus black primes. Okay? Sum of white primes minus black primes given some 2D list. I don't know. Sure. Whatever you want here. That's okay, as long as it gets the job done. Now, to find a prime number, right, we could just Google it here, or we could go ask the chatbot. You want to Google it, or you want to ask the chatbot? Chatbot. All right. Nope, that's the wrong one. GPT. There we go. Missed a letter.
Yeah, so we just need to check the primes between 0 and 64.
Well, so the spaces, it's got a 2D list, so it's a list of lists. So we have got 8 rows, each with 8 items inside of it. Every other one will be black or white. So I can say, hey, the first square will be white, or the first square will be black. Every other square changes. And then if it's prime, and I'm on a white square, I add it. If it's prime and I'm on a black square, I subtract it. Value is prime or not. See what we get here. Now, usually there's a couple optimizations here that if you write your own, people don't think of, because as much as we love math and we've gone through a lot of calculus, prime numbers have been quite a while back. We didn't really take any number theory classes. So the common one is you can actually stop looking for factors at the square root of the value. There won't be any ones above that. I only know that because I've done this so many times and I like prime numbers, that's all. So less than or equal to 1 is false. Less than or equal to 3 is true, because that's 2 and 3. And then if it's mod 2 or mod 3, it's not. And then looking for I times, what? Check for divisors from 5 to the square root of the number. Okay, sure, square root of the number. I times I less than, okay, so that'll be the square root of the number, right? If we're taking our I is the value we're modding.
Why they set it to 5?
Because we already checked 2 and we already checked 3, and then we know 4 is not prime, so now we're going to start at 5. So 5 is the next number, and then I start adding. I'm adding 6, so I get to 11 and 17 and 23 because it's not a factor of 2 or 3. No one comes up with this. This is nonsense.
As we are dealing only between 1 and 64, 64, isn't it easier just for you to have a list with the prime numbers between them?
Well, so you can have any value in those squares. I could have 2,732,312 as a value in that space. There's just 64 spaces in that list.
Yeah,
it's
but
not.
when we're talking about like between 1 and 64, because we're gonna have only 64 pieces, right? Like,
Yeah, there's only 64 spaces, but any number can go in any space. Any integer can go in the space.
oh, okay.
Yep. So sure. Or okay, and we're also adding 2. This is nuts, but okay, sure, let's try it. Let's take this here, and we'll throw this in. So I need the isPrime function here.
If you have a function like this, would you mind if you use ChatGPT to find those?
So you can't use it for the entire answer,
Yeah,
but like
for
is
it.
prime, yeah, go for it. Yeah, and that's what I'm doing here. So UMGPT prompt. Right, we cited our source. I'm happy, right? And it's not the entire question. Right? English paper rules about you can't give me one giant quotation. Part of it, sure, 50%, perfectly fine. It's just a part of your solution. I'm okay with that. And it's not by like lines of code, because the rest of our function will be really quick. But sure. All right, so now we're going to say, so this is some two-dimensional list, so I need to know if my square is white or black, right? And that will alternate as I go. And then I'm going to go through every list. So maybe we'll say, I don't know, is white square is true to start. And then for, now I'm going to use, yeah.
Can you go back to the question, because I kind of forgot what they asked.
So we need to pretend we're a chessboard with all the white and black squares. We're summing the prime values on white squares minus the sum of prime values on black squares. Yep. So every prime number on a white square we add, every prime number on a black square we subtract. So we'll assume the first square is a white square. If you wanted to start as black, that's fine too, and it doesn't really matter. There's probably a right way to do it, but I don't remember what it is here. So for now, we want for every row in my sum2D list. So now I'm going to loop through all 8 rows. We didn't have to validate this was an 8x8. It would be nice if we did, but we're probably going to give you an 8x8 because it didn't tell you otherwise. And then I want to check for every value. And then for value in the row, now I want to do something. Right, so this will give me the actual number that's there inside of the 2D list. All right, the list of lists, the inner list has a bunch of numbers. Okay, so for every value in the row. So if the number is prime, so if is prime given the value, then I need to go add it if it's white, subtract if it's black. So I need a total here then, right? Starts off at 0. So if it's a prime number, and then if is white square, we will take my total plus the value. If it's not a white square, I'll take my total minus the value.
Well, how do you know it's a white square?
So I'm assuming the first square is white, and then regardless of that, then after I've checked here, I'm going to say is white square equals not is white square. Go to the next one. So after it's a white square, opposite of white is black, not white. When it's not white, the opposite of that is what is white. So this will just alternate every other. So if we just think of like the first square is a white square, let's check it. The next square is a black square. Let's check it. The third square is a white square. Let's check it. On and on and on. I get to the end of that one and I go back. Let's just double check, make sure that works here. So chessboard. So at the end of my chessboard here, right, if I go to the black square, the next one, ooh, is still a black square. So we get repeats in a row at the end of the list. That's unfortunate. So at the start of every row then, we want to flip it one more time. Sure. So I'm going to actually start this as false just for fun here, and I'll say is white square equals not is white square. So the first row will start as white, and then we'll go through all of them. So we'll have white, black, white, black, white, black, white, black. And then I'm done my values. Right? I go to the next row when it's, so we just changed it, right? So we knew it was black on the last one, it changed it back to white. We go to the next row, we say, okay, change it back one more time. So it goes back to black. And I have black, white, black, white, black, white, black, white. We change from white to black, and then we go to the next row and say, okay, next row, change it back to white. The next row starts with a white square. So I think that'll probably work. And again, we could test it out. We could try it and see. I would give it like maybe 3 numbers in a row right on the edge to make sure it's going to check right and see what we get here. And there's lots of different ways to do this, right? If you use indexes, you can go off the index. You can add in rows and lots of different ways of doing that. Things with, doing mod 2, You can add in the row number. So if you have your row index, you know the first value on even rows is white, you know the first value on odd rows is black. And you can start it that way, right, if you wanted to. Instead of doing the flipping here, this is a little weird here, I guess. We're gonna try it that way instead. Or I'll leave it as two different loops here maybe. So we'll say, so we'll do repeat here. Now I want to say for row index, or row index and row and enumerate, maybe? 2D list, some 2D list. Right? We can say, is a white square will be my row index, mod 2 equals 0. So even numbered rows will start with a white square, right? 0, 2, 4, and 6 start with white squares. 1, 3, 5, and 7 start with black squares. That's just another way to do it if you like the math of it here, rather than trying to flip it at the start of every row. This might make a little more sense, right, to do it that way. I think it's row index, right? Do we get the row index first?
Yeah.
We get the iterable, nope. So row and then row index. Yep, that should work here. And again, we can test it out and see. So let me comment this one out, I guess. Let's do edit code comment. Right. So now we can go through then for every value in the row. If it's prime, great, add it, subtract it. And then we're done, right? We'll return the total. Okay, so if you want to test that one out then, I'm going to make a 2D list. Right, so my sum, 2D list will equal a list of lists. And I probably should give it 8 values here, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Right? So that one should be 0, right? Because there's nothing here. But if I would like add a couple prime values, so if we had say like a 3, that would be a white square, and then a black square of 5 would be subtract, and then 3. So this should be 1, right? Because this will be white, white, and black. If we think of our chessboard, right? So it should be 6 minus 5. We should get back 1. So we can just print it here. Like we could write a unit test, but this is fine too, right? Just a quick little play with it. So we should get back a 1. Oh goodness. No, did I have it backwards? I can't do row index mod 2. Okay. So it is row index in the row. I thought I had it self. Whatever, that's fine. It didn't like it, let's try it again. Yeah, now we get a 1 back.
So how do you change row index and row swap their positions to make that work?
So enumerate, I didn't remember what order you get the two values in, because you get the index number and you get the row itself.
Yeah.
Or the value contained in it, which I am calling a row. So before I was calling the row index row, and then you can't modulus a list, because the row index was actually a list.
Row index is like the row you're on, and then the row is the number.
So the row is the value
Yeah.
of the list of numbers in that row. Yeah. Yeah. And or you can use, for range and length of the index or of the row, and then use the index notation, any sort of notation you want here. This is all just whatever you like to write your Python, right? So I think this seems to work here, right? We could try other numbers if we want to, throw another 5 in here. So now we should get up to 6.
0?
I'm sorry?
The answer should be 0, right?
Oh, so this will be a white square, this will be a black square, this will be a white square, so this will be a white square. So I expect this one to be 6, right? Because the first row starts with the white, and the next row starts with the black, next row starts with the white. So,
11 minus 1.
yeah.
If it's like 1 minus 1, well, it's 1 minus 1, right?
Well, so 3 minus 5 plus 5 plus 3.
Oh, okay. It's actually, okay, I see.
Yep. So the questions are a little bit nonsense, sorry. It makes it a little harder for chatbot to answer the entire question, and then hard to Google too. And the other, when people used to use, before chatbot was super popular, when they would use Chegg in places, it's super easy for me to go on Chegg and search for sum of white values minus primes. This only ever shows up from my test here, because it's just stupid. It's not a useful exercise. So I give it these crazy names, I can find my questions on Chegg. That's all.
No, because I thought it was like, if you find a prime pay, if like, I thought it was, I don't know where. If the spot, like place 3, is a black one, we know that it's a prime number and it's a black one, so we can add 1 for black.
You're going to subtract the value.
Okay.
So you're taking the value of the number there and subtracting it from black squares. The value that's on a white square and adding it.
Okay.
I'll try and give a better example here, a question and then an example of what that looks like when I do this, because it is crazy nonsense. Yeah, if you're not sure, just call me. Like, I will probably be able to pick up the phone most of the time.
So literally just call you?
Just call me, yeah. Or try me on Discord, but call me is pretty easy. It'll usually work. Right, so I feel pretty good about this one. Right, we ran a quick little test. It seemed to work okay. We didn't test it exhaustively, but I think this was pretty sufficient. We good? And then the last one are iterative and recursive functions for standard deviation. So to calculate standard deviation, we need to find out the average of the list, and then we subtract the number from the average and square it, right? And then take the square root of all of those summed together. I think that's what this was here. Let me go look again here. For population standard deviation. The formula is crazy, but that's okay. Ugh. Why? Yeah. Let's sample. I want population.
We get 11 there.
Yeah. So the sum of the number minus the average squared times 1 over the number, or divided by the number of values, square root of that. Should be our population standard deviation. It's a couple steps. Unbiased. I feel like there's a better formula for it that was a lot easier to see.
Yeah, I remember there was.
Which one do we use? It's distributions, standard deviation of the mean. Deviation. Oh my goodness. Which one do we use? There was a formula for standard deviation. All right, I guess this is what we get here. So the difference between population and sample is the n minus 1. That's all. Yeah, I think. Yeah, okay, the variance I think was the easier one to use here, right? So we get our mean here, value minus the mean squared, summed all together divided by n is your variance. Take the square root of the variance. I think we did it in a couple steps. But that was the idea, right? So we'll go and write 2 functions for it. So let's write the iterative function first. So standard deviation, given some numbers. So the first thing I need to do is get the average. So my average is going to be the sum of some numbers divided by the length of some numbers. Right, now I have an average, and now I need to get the sum of every value minus the average squared. So my variance, right, will equal, starting at 0 and then for value in some numbers. You can say my, variance, there we go. Variance plus equals the value minus the average, right, in parentheses, make sure we do that one here, squared. Right, we sum them all together, and then take our variance divided by the length of some numbers, divided by equals, right? Right? That's that last step here. So add them all together, divide by the number of values. Right? We calculated the average, added them all together, added all the squares together, difference is squared, divided by that, and then the square root of that, and then we can return the square root or variance to the power of 0.5. Okay, and for cheating for square root, or you could use the math import. Right? That would make sense? So this is pretty quick and easy. So what we need then, the info we need is to do the loop, essentially, right? My recursion will take the place of the loop as I go here. So define standard deviation recursive, given some numbers. Deviation. Now, the outer function should still just take some numbers, but we'll probably then need a helper function, right? A private, the standard deviation recursive that has a bunch of other values. So we have some numbers, and then I have the average, and then I have a total, or I have an index, or which one I'm looking at. So I probably have the average, and then the index, or current value index, or something here. I can work on a couple different ways we can replace essentially this loop is what we're trying to do here. So I need to know what the average is. I can loop over every value. And then I need to know which value I'm currently on. So I need to know when I can end my loop. Right? And then I'll probably give back that variance then. Right, as we go. So the variance. So we'd start with the sum numbers, so we'd calculate the average, right? Average is still the same, is the length, or the sum numbers divided by the length of some numbers. So now I have an average, and then I can say, starting with the current value index of 0, right? We can return the standard deviation recursion piece here, given some numbers, given the average, starting at index 0, and the total variance starts at 0. Right? We're going to keep these variables passing along as we go instead of keeping them as loop values. Right? I don't need a counter here that I'm using in the loop. I'm going to just be passing it along as I go inside of here. And then so we're going to take all of that, then whatever we get back from that, times 0.5, right? Or to the power of 0.5 to get the square root when we're done. So this one then needs to see, did we reach a base case or not? So the base case then is if our current value index is greater than or equal to the length of some numbers, we can return the variance. We're done. We reached the end. That's how I know I'm done, right? I had 5 values in the list. I got to current value index is 5. Stop to give back the total variance. If I'm not there yet, then I have more work to do, right? How do I make this one step simpler? Well, whatever number I'm at, do that work, and then increase the number by 1. I will approach the length of some numbers as my index here. So to do that work, then I'm going to take my total variance, I'm going to add to it the sum numbers at the current value index minus the average squared right? Squared. Oh, we missed one step, so we'll take that total variance divided by the length of some numbers. All of that then to the power of. And exponents go first. We gotta be careful with that one. Right? So we'll get the total variance, then we're gonna add some numbers, so whatever value we're at, minus the average squared. So we're adding total variance, and then we're gonna return my total variance. I'm sorry, we're gonna return standard deviation recursive. Right? So we still have some numbers. That one's still the same. We still have the same average. My current index went up by 1, so current value index plus 1. Whatever it was, add 1 to it. And then the total variance that I'm currently summing. Right? I just added something to it, so go add to it. Right? Take the value just added. So the first time this runs, say I've got 5 numbers. We have 1, 2, 3, 4, 5. Right? If we do 1, 2, 3, 4. This is silly to do recursively. It's just an exercise. So the first time it runs, right, we're going to call this recursive function here. So the average is 3, right? 6, and 3. It's 15 divided by 5. Yeah, 3. Average is 3. So average is 3. My current value index is 0, right? And we're going to call it. So we're going to take 1 minus 3 squared. So we'll have 4. So my total variance then gets set to 4, and I recurse, right? So now I'm calling it again. So average is still 3. My current value index is now 1, and my total variance is 4. So now I'm going to take 2 minus 3 squared. So I add 1 more, add the total variance. So total variance is now 5. Right? And then I'll call again. So average is still 3, current value index underscore, there we go. Value index is 2, total variance is 5. Right? So now we're going to take, okay, index 2, 3 minus 3 is 0, nothing happens. Right? Nothing changes. So now current index goes to 3, total variance is still 5. Index 3 is 4. 4 minus 3 squared, I add 1 more. So now my total variance goes to 6. And I recurse. Right? Call it again here now. Index of 4. Now I get 5 minus 3 squared. Right? 4 more. Oh, sorry, that should be 6. Total variance was 6. So now my total variance goes up. Variance goes up 4 more. So now my total variance will be at 10. Right? And then I recurse. Call again. Current value index becomes 5. I added 1 to it. Now I hit my base case. Right? I'm going to return total variance. I'm done. I got to the end of the list here. So I'm going to return 10. Right? 10 gets returned, which 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 gets returned. So the very first call to this, I get back 10. Then at the end of that, I'm going to take 10 minus the length of some numbers. So I'll get 2, and then I'll get the square root of 2. So hopefully that shows up. What is the standard deviation of 1, 2, 3, 4, and 5? What is it? Look at that. It's even a suggested thing. Population standard deviation, square root of 2. Ha-ha! It worked. I'm always happy when math works, because often it doesn't the first time. So it should do it, right? So all we've done is replace this loop here with a recursive call. That's the basic recursion, and if you can do that, you don't need recursion. So this is just an exercise to make you do it recursively because it's obnoxious. That's all. So if you can do that, then I feel pretty good. You can do that some basic recursion. Our project had us do the advanced bit of recursion that is a better way to use recursion than just a loop here, right? That's all.
Could you please go over very quickly those, if you don't mind, of the first questions?
Yeah, definitely. All right, let's take a look. Question 1, enter your name. Sorry. Yeah. All right. A linked list generally uses more memory than an array-based list. Is that true or false? Remember, with a linked list, we have to keep all those pointers, especially with the doubling link. I have to know what comes before me. I have to know what comes after me. So I have additional information I'm storing for every piece of actual data that I care about. So generally, this is true. Right? With an array, I have space to store a bunch of values. That's all I need. I don't need to store what comes before, what comes after. So linked list will use more memory than an array-based list. Why is it important an array-based list has a contiguous block of memory for storing values so that you can do that index access? Hey, at index 5, it's, well, where's the start of it times 5 memory addresses? Jump 5 out. Right? You get the instant access. Have a good one.
We have it on the quiz, right?
On trees we will, but I'm not going to post it till after the midterm.
No, we had that question.
Oh, yeah. All these should be on the quizzes. Yep. 3 main ways of interacting with a stack. You can pop, you can push, and you can peek with the stack. Write a recursive function that accepts a list and reverses it. We could do that one if you wanted. Right? This is without returning a new one. So use the private helper function. You want to write one of these? Okay. So this is define reverse list given some list. And then again, we want a helper function here, right? So the helper function needs to know all the other stuff. So reverse list.
What exactly is the helper function for?
So if you want to ask for the standard deviation of something, you don't want to have to tell me what the average was, what the current value index was, and what the total variance was. I want to give you an easy to use function. All the other stuff I'm going to do as a private helper function, because I don't want the caller to have to do that. So to get the reverse list, you just have to give me the list, I'll reverse it. But the way we're actually going to solve it here, reverse the list, given some list, and then the start index and the end index. Right? So you tell me where to start and where to end, I'm just going to swap those two values and then recurse. So I know I'm done if my start index is greater than or equal to the end index. Then we're done. Or right, if we're not, right? I guess if we're not there, then we can keep on going. So if I'm not greater than, if I haven't passed this point here, I'm going to start swapping. So I'll say my sum list at the start index, let's say like temp, is equal to sum list at the start, and then sum list at the start index is equal to sum list at the end index, and then sum list at the end index equals temp value, and then we recurse, and then we call reverse list given sum list, and I take start index plus 1 and end index minus 1. Keep on going. right? If I reached the middle and they're the same, I don't have to swap anything. And if I've passed each other, I'm done. I've already reversed it. So now I can just call reverse list, given some list, given it 0, and then length of some list minus 1, right? Because we want a valid last index there. So there is no index 6. There's no, the length is 6. So start at index 5. Right? That's all. So the private helper function has this. So we could do this exact same thing with the loop, right? I could have a loop that says while start index is less than end index, do this step here. Now we're just using recursion to have these values here. That's all that one was. Yep. An array-based list deliver O of 1 operation speed when accessing any element at a given index. Well, that's this question here. This one, right? Because you can find where that is based on the index of it, offset from the start of the array value, right? Recursive solution only have a single base case. That's false. You can have as many base cases as you want, right? Either you've solved it or it's a dead end in some cases, or I know what the answer is or I don't. A couple different ways, but not only a single base case. That's false. What does remove method do in a list? What happens in a list? So when you remove a value, everything has to shift back in place. So our lists keep index. So if I remove the 5th thing, everything after 5 has to slide back 1. So we'll take, the n k minus n or n minus k operations, but we have to backfill. With a linked list, we don't. Our regular list, our array-based lists, we do. So these are slow, right? The bigger my list gets, the slower this happens to be. The node class in a linked list is meant to be public, and offer and others should interact directly with the node when using a linked list. That one's false. Node is a private inner class. No one needs to know how we're tracking our linked list. They never interact with node directly. They just interact with the linked list, with the functions, or maybe a position when we start doing the position wrapper, but never node. When looping through a linked list, you follow the links from each node to get until the end or back of the dummy node in a circular linked list. Yeah, follow the pointer. So go to the next one, go to the next one, go to the next one. Either you get to the end, or you get back to the dummy node if we're a circular list. Yep. 3 main ways of interacting with a queue. You can get the front value, you can look at the front value, you can NQ, or you can DQ. Right?
Q to Q from.
Yep. Easily solve with recursion, like the towers of Hanoi. Why is that a good solution instead of the iterative approach? Because it's very simple. Like it's move this, and if I can't move it, move 1 less, and then move it, and then move 1 less. Right? So it just breaks down very easily with recursion. You don't need a whole essay here.
And even like the night store.
Yeah, those are some backtracking recursions are really easy. They're not necessarily good approaches. There are better ways to solve mazes and do some of those things. I don't know if I would. It's an easily solved with recursion. That's true. Why is it good? That one's a little tough with like the Knight's Tour. There's probably better ways. If you say something like factorial, that's wrong. It's not a good approach. That's just a loop. You don't need recursion when it's just a loop. So things that are simple loops aren't good approaches with recursion because you just need a loop instead. It actually takes more memory to use recursion, but easily solved with recursion. Like how many files do I have in a folder and it's subfolders and subfolders and subfolders and subfolders. Easily solved with recursion. It's a good approach because otherwise it's a big pain. You have to manage this queue and do all those sorts of other things here. Right? It lets us avoid having to manage it ourselves. When using a linked list, the worst case time for appending is O of 1. That's true. Because we always know where the end is, we just add. It doesn't matter how many n items we have. There will never be a resizing that happens. Like worst case.
For appending, you just add it.
Yep. So with a regular list or an array-based list, when we append, occasionally the worst case is O of n, because we have to copy all of those items to a new, bigger list.
Okay.
The worst case is slow, but it averages out okay. So on average, it's fine, but specifically worst case here. Stacks and queues can be created using a circular doubly linked list and have worst case performance of O of 1 in all of their functions. That's true. If we're using our circular doubly linked list, we can do stacks and queues very easily. Everything is instantly fast because we have the links here. It never has any resizing. Right? The worst case here again, because it's a linked list, everything's super fast. We can get to front, we can get to back. Average time to add an item to a given index in a linked list is O of 1. This one is false because you have to get to that index. If you have a position, you can add to before it or after it, O of 1.
Search, right?
Yeah, but if I just say, hey, add this to index 37 in a linked list, I have to go step 37 links and go find it.
Okay.
And then I can go ahead.
You will be linked.
Yeah, O of n. Yep, and that's all those questions. So, awesome.
Thank you so much, sir.
Yeah, no problem. Have a good one. So I won't see you Thursday. See you next Tuesday then.